Hi everyone, my name is Kevin, the lead developer of this autopsych website and app. Today, I will demonstrate the Anova tab of this autopsych sharing application, which allows users to perform Anova with immediate results. That is, to examine differences between groups for a measurement of interest. As an example, I will run through an ANOVA that examines the degrees to which student performance differs by school and gender groups. So when you launch the Shining application, this is what you will see first. And to get into the ANOVA tab, you click on this ANOVA tab at the top. Just briefly, one-way ANOVA stands for one-way analysis of variance. That is used to determine whether there are any statistically significant differences in the average measurement of interest between three or more independent groups or interventions. If you want to compare between two groups, then you can use two sample TTs instead. However, in theory, you can still use one ANOVA to determine differences between two groups. This tab here will take two data inputs. First is the Excel outputs from the unidimensional RASH tab, and the second contains an Excel file comprised of a grouping variables of interest. So in this demonstration, we will use this TIS ANOVA response file generated from the unidimensional RASH tab, which contains the ability theta variable, which is a special type of a percentage correct score. We'll also use this file called TIS ANOVA group Excel file, which contains grouping variables. Note that each element corresponds to the same participant between two input files, which can be merged based on the participant ID. So to load up these two files, you just click on this browse button. Then you can go and search for the files that you want to upload. Once you load up these two files, you can see the drop-down menu automatically shows the grouping variable of interest from the grouping data. We'll first compare the ability theta between schools, and box plot shows school D has the highest ability theta compared to the other schools, followed by school B as an initial exploration. We can check the normality assumptions by clicking on this normality check tab. Here, even though the superior work TIS indicates that there's evidence the residual of the ANOVA model is not normally distributed, but by visually inspect the histogram of the residual, it looks pretty normal. That does have this sort of bell-shaped curve. So the ANOVA TIS is quite appropriate. Also, note that we have a large sample size of 127 students, so the normality assumption should still hold based on the central limit theorem. Moving down underneath this diagnostic plots, we can see the ANOVA results. The ANOVA table helps us to understand how much student ability differs between groups in this case, between schools. The sum square columns give us insights into the overall differences in the students' ability, both between and within groups, or residuals. The between groups sum squares is calculated to be about 18.6, and for the residual sum squares, which captures the overall variations in student ability within groups, we get about 144.04. Mathematically, we then can divide the between group sum squares by the unique pieces of between group informations, that is, by this 3 degrees of freedom, to get the between group mean squares of 6.2. We can also divide the residual sum squares by the unique pieces of within group informations, that is by 123 degrees of freedoms, which will give us a residual mean squares of about 1.17. We then divide between group mean square by the residual mean square to get the F values of 5.29. The F value helps us to determine how likely the differences between groups occur completely at random. Lower the p-value suggests the result is more statistically significant, and the p-value less than 0.05 are commonly thought to be meaningful, although there has been a more recent push towards making this more strict at less than 0.005. Moving across this Anova results, we can see that there is a strong evidence the ability theta between schools are different. Clicking on this estimated marginal means will allow the user to check which schools' estimated average ability theta are higher. As you can see, school D has the highest ability theta. Then the two key pairwise comparisons allows the users to check if the ability theta of school D is statistically significantly different from the other schools. We can confirm that by looking at the p-values of the comparisons to school D. We can see the p-value compare school A, B, and C are all less or roughly less than 0.05. Note that this p-value has been adjusted for multiple comparisons. Further, the ability theta are generally not different between school A, B, and C, as you can see from these p-values. Moving on, we can then also compare this ability theta between genders by changing this drop-down menu here and selecting a different grouping variable, which will provide a same set of results for the users to inspect. And finally, thanks for watching, and hope you'll find this application useful for your research.